So today I'm going to talk to you about full stack development with Swift and talk about how we can reuse some of our code on both the server and iOS and why we should use Swift for full stack development. So by the end of this talk, you're going to be going back to your companies, back to your clients, back to your bosses, going, let's server-side Swift all the things. Maybe, we'll see. So, quick introduction about myself, and a nice floating icon there that shouldn't be there. So I'm Tim. Believe it or not, I actually have a day job as a mobile developer at the BBC, and I work on the mobile platform team in media services. And we basically make all of the components that are common for playing back media across BBC apps. So that could be the video player that lives in iPlayer, BBC Sounds, and BBC News, that plays back all the videos, or it could be things that manage downloads and DRM encryption and stuff like that. A couple of years ago, I also founded, well, probably about 3 or 4 years ago now, I founded a company called Broken Hands, and these days it is all exclusively doing Vapor stuff. So that's doing training and workshops in companies and at conferences like this, and writing custom Vapor packages and software and apps. I'm a core contributor and moderator for the Vapor framework, and I'm also the server-side Swift team lead at raywendelick.com. So I'm completely unbiased when it comes to server-side Swift, as you'll see during this presentation. You can follow me at Twitter and GitHub and Slack and all those kind of things as 0xtim, and that's 0x as in hex and not OX. That really confuses some people. I don't know why. And I organize a number of meetups and conferences here in the UK and also around the world. So last year we had the inaugural Serverside.Swift conference, which was the world's first conference dedicated to server-side Swift in Berlin, and this year we're back in Copenhagen. And also organize NS Manchester with Chris, which is a monthly meetup, iOS/Swift meetup in Manchester. So if you're local in the area, come along, because it's a really nice meetup once a month, really friendly. So a quick survey for all the people I can't see because the light's in my eyes. How many of you consider yourself to be full stack developers? 1 or 2? Or how many people write some back-end code when they have to? So that's quite a few. How many of you, with those hands up, work for companies with, say, more than 50 people in? And that's kind of shrunk down quite a lot there. And that's kind of quite common. So why would you write full stack? Why would you do full stack development? Well, back in the day, in the good old days, as some people like to think, when we did waterfall, your architects would write all your software up front in UML, and you get given a dump, and then you go and implement that code. And because we never made any mistakes, it was always right. And the back-end teams and the front-end teams didn't really need to talk to each other, because it was all defined up front. We've realized that the world doesn't really work like that anymore. And so we kind of have to be a bit more agile, move a bit quickly, or at least call ourselves agile. And separated front-end teams and back-end teams just aren't agile. You can't develop quickly, you can't move quickly if the teams are separated. I don't know if any of you have been in this circumstance, but we've certainly had this quite a lot at work, where, oh, we need the change on the back-end, we need something new in the API, a new feature, a new endpoint. And you go to the back-end team, it's like, yep, just file a JIRA ticket, we'll come to it in maybe 2 weeks or the next sprint, and we'll see if it's high enough priority. And it may never get developed. So that's why you should do full-stack development. But why not just website stuff? Well, over the last few years, there seems to be a bit of a trend. And maybe it's just my personal view and what I've seen, but it seems to be a move away from websites towards apps, especially in the enterprise world, where companies want to develop internal apps rather than internal websites. And things like progressive web apps just aren't really living up to the hype. There was a few years ago, about 2 years ago, when they kind of launched, there was a lot of excitement around it, but it hasn't really come to fruition. React and cross-platform apps, they have kind of too many disadvantages. We've seen companies like Airbnb move away from React native because you end up writing for 3 platforms instead of 2. You end up having to fix bugs low down that would take you a few hours in native code. And it just slows you down. And also can give you a really poor user experience. I don't know if any of you have used apps like Monzo or any kind of new fintech apps. And if you compare that to your current banking app or your old school banking app, say like the Halifax app, there's a really noticeable difference between the apps. One's really good and one's terrible. And you can really tell that it's not a native app. iOS is still the market leader for most things, especially in business. I can say that because all the Android developers are in the other building, so that's fine. And basically, all roads lead to Swift. That's my complete unbiased view there. So why we use Swift on both the front end and the back end? Well, as we know, Swift's a really modern, really popular language, and it's growing really quickly. It's being pushed at really young ages with things like Swift Playgrounds and the incentive to code with Apple's programs. And so it's really getting a big momentum behind it. It's backed by Apple, which means that you know it's not really going to go away anywhere. About a week ago, I could have made a nice joke about Google dropping stuff, and then AirPower happened, so that joke's gone out the window. But it is open sourced, and it gives you a unique opportunity to be able to contribute to the evolution of the language itself. Swift has really seen an embrace from the community and allow people outside of Apple commit code to the actual Swift runtime, the compiler, the language, and be able to submit evolution proposals, which is something that other languages don't really seem to have. It's really modern, so if you look at some of the languages that are used on the back end, more traditional languages, they've been around for 20, 30 years. And some of those languages were not designed in the world we live in. Whereas Swift has managed to take all the good things, learn all the lessons that those languages have learnt, and develop a really nice language and not bring all that tech debt over. It's really safe. So Swift is a strongly typed, statically typed language, which means things like null pointer exceptions should just never happen. Optionals are really powerful and allow you to really have confidence in your code that things are there when they say they're there. Whereas if you look at something like JavaScript, you just kind of throw around nils and undefined, and it's kind of a feature, not a bug. And Swift is also really fast. Swift has the potential to give you near sea-level performance. And we all know kind of how things like JavaScript and PHP work. But the most important reason for why you should use Swift on both the back end and the front end is it's not JavaScript. I mean, it's a low blow, but we all realize that JavaScript's a silly language. So, what about Vapor? What is Vapor? So Vapor is an open source web framework written in Swift, and it's created by a guy called Tanner Nelson shortly after Swift was open sourced and released onto Linux. And Logan Wright kind of came on board pretty soon afterwards. These days, it's built on top of Swift Neo. So Swift Neo is Apple's event-driven, non-blocking I/O framework. It's very similar to Netty and Java if you use that. But it handles all the really low-level stuff like socket communication, HTTP, HTTP parsing, WebSockets, security stuff. So it's all the really gnarly code that you really don't want to be handling, as well as things like threads and event loops. And they've done a really good job on it. And their engineers are actually available. You can just ping them on Slack and Discord, and they'll answer your questions and they'll help you, which is kind of very un-Apple of them. Vapor has kind of taken a stance and differentiated itself from Katora, which is kind of the other main server-side Swift framework, in that it's not afraid to break things. It's not afraid to embrace modern technologies. So Katora is basically has been written by IBM, and it has a lot of influences from IBM. It's very enterprise, which means they have some enterprise apps, and they can't just go and break their API for the next major version, because all their enterprise apps would have to be upgraded. So they tend to move a bit more slowly. Whereas Vapor, when Swift Neo came out, within a day and a half, they'd moved to Swift Neo. They are not afraid to say for Vapor 4 it will be Swift 5 only, and things like that. Which does have some downsides, but it does mean that you get to build on a modern API. If we all had to still write Swift 1 code, we'd be hating life. It is also one of the most popular frameworks out there compared to any of the others. It has a lot more activity behind it and a much bigger community, and there seems to be a bit more of a mind share. And the community is amazing with Vapor. There are hundreds and hundreds of developers out there who are always active, always on the channels and the forums, getting involved with the evolution of Vapor. So if you're a web developer, if you're a developer or a business, why would you choose Vapor? Well, you get happy developers. So if you can write Swift on the back end as well as the front end, you tend to be a bit happy because you don't have to learn another language. You already know Swift and you've used it in iOS. Why not just use the same language in the back end? You get a compiler. And coming from the web world, this will just blow people's minds. You know, something can tell your code does not work before you ship it, or even build, which is amazing. Something we take for granted. You get to use the same tooling as iOS, so you can still use Xcode. You can still use all the tools you know and love. You can use instruments to profile your server apps, and because you don't have to learn anything else, it just reduces that barrier to entry to learning it. And you can debug in Xcode. So if you've got a bug in your server-side app, you can just put a breakpoint in there, step into it, look at what's going on. whereas some of the other dynamic languages have really kind of struggled to embrace this kind of thing. Now, if you're a business, why would you choose Vapor? You know, you might have established teams writing PHP or Node.js or anything else like that. But it all comes down to money. Like anything else in life, it's money. So Vapor especially, and Swift Neo, they're completely non-blocking from the full stack all the way down to the data race drivers. And this does have a little bit of a disadvantage when you have to try and learn what's going on. But it does mean that because it's non-blocking, you can handle far more requests than you can handle in a blocking environment. And because you can handle more requests a second, you need less servers. Vapor's memory footprint is also absolutely tiny. So a basic Vapor app will take up about 6 megabytes of memory. That's not a typo, 6 megabytes. So if you're comparing that to something like PHP or JavaScript, we all know how much memory Slack takes up on our laptops. You know, so these are orders of magnitude less. And if you're doing something like a microservices app, where you might have 10, 20, 100, 150 little microservices, if they're all running on just say 6, 10 megabytes of memory compared to half a gig of memory, that's far less memory you need. And that's a massive cost benefit that you can take back to your business. And it's also safer. You're not going to have crashes in the middle of the night because you've had that compiler, you've got a decent language that will catch a lot of these errors up front. So how do you deploy Vapor? Well, Vapor runs on Linux and Mac OS, but Linux really. So you can deploy it onto Ubuntu, but because it's Ubuntu, you can deploy it to anywhere where Docker is, which basically means anywhere. There's also some kind of platforms available for you, or platforms as a service. So Heroku and Vapor Cloud, which will basically, you give it your app or your GitHub repo, and it will just build your app and deploy it for you, and you can do it in a single line Vapor Cloud deploy. It's really handy. There's some really good free tiers as well. So one of the questions I get asked a lot is it ready for production? And obviously the answer is yes. There's a few caveats, but mainly it's yes. So with the release of Swift 5 and Swift Neo 2, we're kind of starting to see a bit more stability in the ecosystem. And it's really starting to kind of find its feet and become a really good language and framework. There's a Swift server working group, which is founded by Apple. It's part of the Swift.org site and ecosystem. And it has representatives from Apple, from Vapor, from Katura. And their aim is to basically grow Swift on the server. And they're really trying to build the ecosystem at the moment. So for 95% of apps out there, you can just pull in a library that you need and get going. However, some of these libraries might not be fully supported. Some of them might be missing. So their aim is to basically build a library of really good libraries, or a group of really good libraries that you know can trust and are battle tested. So things like logging and metrics and monitoring that are really important. Things like OpenAPI, which is kind of asked for a lot but not really considered much. Things like database drivers that are really hard to get right, but battle-tested database drivers built on top of Swift Neo. And things like authentication. And the great thing about this is that if you have a package, or you can think of a package, you can propose a pitch to the working group, and they will take you in part of the incubation process and guide you through to releasing an approved package effectively. A really good example of how the community's kind of rallied around this was about a week ago or 2 weeks ago. There was an issue that someone posted on Twitter saying that their Vapor app was consuming 4 gigabytes of memory when it was running in production. This obviously is something that shouldn't happen. And there's a really good forum where Apple Swift compiler engineers, the Swift Neo team, the Vapor core team, and other members of the community all dug in to work out what was going on and fix the bug. It's a bit of a plug, this, but it's there. The Serverside Swift conference last year, there were, I think, about 20, 25 talks of companies showing you how they were using Swift in production. And it actually really surprised me of the number of companies that were willing to stand up and say, we use it in production with real users. And there's some really good examples there. So things like Mercedes, ING, they both use Katura for audience or kind of public-facing apps. There's an agency in Copenhagen and London called Nose Agency. About 2 years ago, 2.5 years ago, they said, we're fed up with PHP, we're going all in with Vapor, and any new apps they write will be Vapor and Swift on the back end. And this is an agency with real clients. And they have some big clients like Ariva Arriva trains that are using Swift in production. Allegro is kind of Poland's Amazon. They are using Swift in production, and they've seen huge cost benefits from doing things like image processing with Swift, seeing massive memory differences. Amazon themselves, they have their own Smoke framework, which is based on top of Swift Neo, that they're using internally, so using Swift in production. The BBC, believe it or not, we actually have some server-side Swift going. Some of our internal test apps are powered by Vapor APIs, and we're looking at bringing those out to audience members this year, hopefully. Apple, obviously, you can bet your dollar that the amount of time and effort they're investing in server-side Swift, they are using Swift on the server for things like iCloud and heavily invested in it. And the Code Mobile app. If you didn't know, the Code Mobile app is powered by a Vapor API written by Matt. So you've been using it this week. So, time for a bit of a demo, because talking at you is not very interesting. So I want to show you a bit of a demo. So there's a couple of things I want to demo today. If I get my notes up. So the first thing is I want to demo how easy it is to get going with Vapor, but only a short thing, because I kind of gave that talk last year. Just get my displays back. And I also want to show you how you can share code between iOS and the server, because that is kind of the holy grail of full stack development, of being able to share code between different platforms. So, you're not going to be able to see that at all. So I have a little package here called Reminders Core, and this is for a reminders app and ecosystem for basically doing reminders. It's a to-do list. It's the generic go-to when doing a demo app. And I basically got two models here. One's a reminder and one's a user. They have some properties, they're codable models, and there's not really much to them at all. But I want to be able to share these. So this library, this package, has actually got a package.swift manifest. So package.swift is Swift Package Manager's kind of manifest file. It's very similar to your pod spec for CocoaPods. And this defines how you can use the source code for this library in your server-side Swift apps. Now, unfortunately, Swift Package Manager isn't supported on iOS yet, at least not without a load of massive hacks. So this library also has a pod spec, which basically just points it at the code to be able to, so you can pull it in with different libraries. So the first thing to show you is I have a Vapor API here called Reminders, and it's an API where I can hit and get various reminders and information about the users. So to be able to use those models, now there's a number of models in the database. There's a number of things you kind of have to do. You have to make it tell Vapor how to use it as a query and save it in the tables. You have to tell Vapor how to set up your tables. You have to tell Vapor how to decode and encode JSON coming in, and how to use it as kind of parameter routing. So I'm going to write some extensions. And I'm going to write an extension for my user to start with. And I can make it conform to my model protocol. And then that's all I need to do, and I can start using this to query in the database. I'm also going to make it conform to content. Content is basically just Vapor's wrapper around Codable, and it tells you what kind of content type it is. So it could be JSON, it could be formula encoded, it could be XML. But it is just basically enforces you to use Codable. I'm going to make it conform to parameter, and this just allows me to use it in path parameters, which we'll see in a sec. And finally, I'll make it conform to migration. And migration is what is run when you first start your Vapor app, and this just saves it in the database and creates the table for you. So I don't have to worry about creating the user table. And that's all I have to do to be able to use it. I mean, there's a couple of other things. So I have to basically tell Vapor to use that migration, and I have some routes to be able to create and update users. So I'll do the same for my reminder model. So it's going to be the same protocols again, although that's wrong. But for this migration, I actually want to do something different. So the reminder has a reference to the user ID of the user who created that reminder. And when I'm setting up the database, I want to be able to set up a foreign key constraint or a reference between those two tables to enforce that relationship. And I can just do that in my migration, even though the models have been in a completely different package that has nothing to do with Vapor. So I'm just going to write my prepare function or override the prepare function. So this will basically tell Vapor to create the database. And then it takes a closure of what you want to do with that database, what you want to do with that table once it's created. So I need to create all the fields and stuff like that. So that kind of handy convenience function there allows me to just create all of the fields in the database. I don't have to worry about what type they are, whether they're strings or integers or UIDs. Vapor and Fluent, which is Vapor's ORM, can actually infer all that from the model. And then I can just set up my reference. So I know my reminder has a user ID property that's going to be linked to the user's ID property. So I can just link those two tables using key paths. So it's type safe. And that needs to be public because it's a public model. So there we go. So I can now use all of my models in Vapor with very few extensions and still use things like foreign key constraints and references. So to show you how easy it is to just create a very basic controller to handle some roots, I'm going to create a create root and a get all root and a get single root for my reminders. So to create a reminder, what I'm going to do is send a post request to the server with a JSON body that matches actually the reminder model from Codable. So I can create a root handler that's going to return the reminder once it's been created. And it's a future reminder because that's an asynchronous request member because it's got to go off to the database. So I can actually decode the data sent in the post request to a reminder and then just save it. And that saves that thing in the database. I don't have to write any SQL. I don't have to worry about anything like decoding it into a proper model. It handles it all for me. And then I can just register this route at /API/reminders using a post request and just point it to that handler. And that's a create handler for a model. That's one line of code. It's all done. So how about getting all of them? I think my bottle's getting nervous for me. So this one is just going to return a future array of acronyms because it will return all reminders because it will return all of the reminders in the database. And again, it's very simple. I just perform a query on the reminder table and return all of them. One line of code again. It's really, really simple to get going with Vapor. So how about getting a single route, getting a single reminder? Now with kind of some more traditional frameworks, what you generally tend to have to do is we'll send the ID of the reminder in the path, so it'll be like /API/reminders/1, and whereas 1 is the ID of that reminder. So you get that ID, you convert it to an integer, and then you've got to do a lookup in the database to be able to find the reminder with that ID and then return it. And if it doesn't exist, throw a 404 error or whatever. However, because Vapor is Vapor, because I've conformed to the parameter protocol, I can just simply return the next reminder parameter. And I'll register that as well. So this tells Vapor that when you get a request to /API/reminders/ the ID of that reminder, use the get handler, and then just return the next reminder that you find from the parameters. And Vapor will handle all of that database lookup for you, it will handle all the errors for you, and it will handle that 404 for you as well if it's not there. So that's basically a simple API. So if I run my app, I should be able to send a request to reminders and get all of my reminders and zoom. Nah. I don't think I can make this bigger for you. However, you can basically see that I have a list. You can kind of see it up there. I have a list of reminders that are finish my book, write my presentation, etc., etc. And so that's basically, I've just created a really simple CRUD API there in a few lines of code. But I did that last year, so that's not very exciting. So let's move on to something else. So I also have here an iOS project. So if I build and run this, you can see I get all my reminders. I have a list of users. The users have got a status. So I'm preparing for my talk, but I should probably update that. Just say, given my talk, and I can update that in the database, and it updates that. And this is all using the reminders from that pod spec, or that kind of CocoaPod. And I haven't had to really do anything. But let's say, for instance, in this completely unrealistic scenario, that I want to add a property to my user to find out when it was last updated. So normally you'd actually update the CocoaPod, tag a release, and then upload the CocoaPod. However, because these are development CocoaPods, I can just do it here to save some time. So I'll add a new property there. And so if I go back to my API, and I open up my users controller, so I have a route here that handles an update request. And it basically gets the user that you've asked to update, gets the data you've asked to update it with, and then just updates those things. So I'm going to set a property saying, I'll build it first so it picks up the property. To be the current date. And then next time my iOS app requests all of the users, it will get that in the JSON request. So if I go back to my iOS app and then open up my table view controller, obviously don't look at any of this code because this is not production code. I'm now really a back-end engineer and not a front engineer. But I have a list of, basically this is how I display the users. When you tap on a user, it takes you to a view controller with that user, and then it just sets the various cells with the name, the username, and the status and stuff like that. But let's do it in here. So this is the main homepage, and maybe I want to see when that last user was updated in the list of users for some reason. So, so I'm actually going to look and see when my user was last updated, and then set the detail text label to be something like their status. And a pretty format. And I've just got a lit extension here to make the string a bit prettier. So if I build and run that, Xcode is caching its build and CocoaPods. So if I build and run that, I have my list of reminders. And then if I go to my users, you can see I have my app here. So if I make sure I'm actually restarted this, my API. So I'm now currently showing off Vapor, should we say. Let's just restart that. When in doubt, turn it off and on again. Thank you, that's good. Ah, that's why. I'm running the wrong project. Okay, so let's say I'm now showing off my terrible iOS skills because the live demo hasn't worked properly. I've updated that. I can go back, and it has not shown me the new status. Yeah, that should be wrapped in an else block, shouldn't it? Live demos are always fun. Thank you for spotting that. You can now see I've got my updated time in there. Now that's not particularly impressive, but then if you take a step back and think about it, I haven't had to write any new code to parse that data coming from the API. All I've changed is my shared model. I haven't had to worry about how my date's being sent over the wire. So I chose date specifically because it's a really hard one to send and receive. So normally with a string or a integer, it doesn't really matter. You can send and receive it in JSON. But with things like timestamps and dates, your JavaScript backend API, your PHP backend API, most likely isn't in the same format as your iOS app. But because it's using the same code base and because it's all using Swift and just JSON encoder and decoder, you don't have to worry about how that's going over the wire. And that whole problem just comes away from you, which is really nice and really handy. And I haven't had to write any code to kind of decode any of the new stuff because it's just using Codable, and I just get that new model. So that was my kind of short demo into how you can share some code. And if you're interested, come and talk to me afterwards, and I can just go into way more detail. But it's actually really easy. You just create a framework with a pod spec in that just points to your source code, and your package.swift manifest that points to your source code. You can write tests for both of them. The pod spec doesn't actually need a Xcode project, so you don't have to worry about checking Xcode projects. And it makes sharing code actually possible. So, next steps. I am not saying to you, go back and rewrite all of your backend APIs in Vapor. As nice as it would be, it's a waste of time. If you have something that works, that's great. However, maybe next time, think about when you need something in the backend, can you do it differently? Start trying to take control of your backend applications when you're writing your front-end apps. And it will allow you to move much quicker and develop much faster. So especially if you have an API that's just for your app. So for instance, if it's powering just your app and nothing else, or if it's running configuration for your app. Something we do quite a lot of work is having APIs for configuration. So it might be determining what kind of version to show, or what kind of pages to show, what a user is allowed to do. If that configuration is purely for your app, take control of that, and then you don't have to worry about going to another team to be able to change that. And try and encourage a more kind of microservices full stack approach. So take control of every feature and have feature squads that do the front end to the back end of just that feature, rather than worrying about kind of whole teams that do just the iOS app or just the backend app. So, some shameless plugs. There's a video course on raywendelick.com. It's about 40 hours long now. There's a book, the second edition came out about a month ago now, I want to say. Edition 2.1 will be coming out probably at the end of the month once it's finished going through the edit phase. And that's a complete book with all the chapters that we finally managed to get in. It works with Swift 5. And then it will be updated with Vapor 4 later this year when Vapor 4 comes out. And I wrote that with the core Vapor team, the guys who actually created Vapor as well. So it's the unofficial, official book. Thank you.
Cool. Any questions for Tim? Let's get some microphones out.
Hi. The Vapor calls tended to throw and return a future.
Yeah.
With Swift 5's result type, is that something that might change, or is that sort of baked into the way they think about things?
So it's unlikely to change with Swift 5 specifically, but going forward with Vapor 4, it probably will change. So the reasons why you can throw and also return a future type are because some of the functions that you do are throwing. So like if you're trying to decode something, the data doesn't exist, that's going to throw immediately. But by the time it's finished decoding, that's an I/O operation if you've got like a stream body, so that has to return in the future. I know for Vapor 4, they want to kind of flatten all that confusion, because it's a bit confusing to have something that can throw and also return a future, instead of just returning a future that either fails or succeeds. So I think going forward, they're going to look at failed futures and successful futures, and that's probably going to be based something on the result type at least, yeah.
Lots of other questions. We'll go. Is there a mic at the back for Neil? No, I'll use mine. All good. You go, Neil.
Yeah, thank you for a great presentation. I was wondering, how would you handle versioning and basically, because you're running a strongly typed system, what if your iOS app isn't updated for, like you change a key in the JSON that is sent or whatever? How would you handle that?
So there's a few ways to do that. So the kind of most important one is if you're doing proper CocoaPods or proper frameworks, those CocoaPods are going to be versioned. So you only update your iOS app when you can take the new one, and so you basically still decode the old API. From Vapor's point of view, what I would probably do is have versioned APIs, so it'd be like /v1/API/users, and then you can just kind of duplicate your code there. You can either have that as separate apps, and the version 1 app points to the old framework, and the new version points to the new framework, and do that with like a application load balancer, or put it on a different domain or something like that, subdomain, something like that. So that's probably the best way about going and doing it.
Cheers. Another question down. Yeah.
Hi, thank you for the talk. What if I don't want to use Xcode and I want to use another editor? How couple or decouple it is from Xcode?
You can definitely do it. So the LSP stuff that's being kind of pushed at the moment is effectively allowing you to choose any kind of editor you want that hooks into LSP, and you get auto-completion, you get, you can do some compilation, you get code formatting, syntax highlighting, stuff like that. So there are plenty of other stuff, editors out there. Atom's got a plugin, VS Code's got a plugin. If you go and see the JetBrains guys outside, they have an IDE just for Linux that works on Linux to help you build Swift stuff on Linux where you don't even need to have a Mac. So you can do it that way as well. So you don't have to use Xcode if you don't want to.
Cool. Anybody else? No, sorry.
Good talk, thank you. What's the headlining features for like Vapor 4?
It's a good question. The main things are it's basically going to change the way that some of the future stuff works. So it's going to be getting rid of the kind of future but also throwing stuff. Fluent's going to change quite a bit, which is the database ORM. So Fluent 3 is kind of very static and very Swift-like, which is great for a very basic ORM, but if you're doing some more powerful stuff, you kind of want to be only select, say, a few columns of a whole row, or want to be able to do dynamic lookup stuff and stuff like that. So it's going to move a little bit more dynamic and stringly types under the hood at least to make that a bit better. But Vapor 4 should be relatively stable compared to the change from Vapor 3 to Vapor 2. So when Vapor 3 came out, it moved from a synchronous to an asynchronous architecture, and it broke the world just like Swift 2 to Swift 3, and everyone got really confused. But I kind of think we're over that hump a little bit, and it should kind of settle down a bit. And it's going to be Swift 5 and Swift Neo 2, so it's building on top of that. But the general API should stay fairly similar, I think.
Anyone else? Awesome. Thank you very much, Tim.